своїм екраном.
Dear colleagues, let's start. Now we have session first, Intelligent Information Technologies. We have 2 hours for 8 presentations. First, our presentation for today is the formation and analysis of gen expression data based on the joint use of data mining and machine learning techniques by Людмила Ясинська-Дамрі, Сергій Бабичев, Alexander Skrivakovsky, and Alexander Lemeshchuk. The presenter is Sergey Babichev.
Yes.
Welcome, Sergey.
Yes. Thank you very much. Yes, I would like to present the result of research focused of formation and analysis of gene expression data based on the joint use of data mining and machine learning techniques. It's one of the current direction of modern bioinformatics. And allocation informative different length space and mutual correlated gene expression profiles can allow us to improve the efficiency of complex disease diagnostic systems such as cancer, various types of cancer, Alzheimer's disease, Parkinson disease, and similar. And more allocation of informative genes can allow us to reconstruct gene regulatory networks for following analysis of character of genes interconnection in order to grade the effective medicines and gradation disease diagnostic systems. The next slide presents the stepwise procedure of this step implementation. Firstly, data formation. It's possible to use matrix of gene expression profiles based of DNA microchip experiment implementation and more effective and modern methods of RNA molecular sequencing. We use it within the framework of our research, the second method, RNA molecular sequences, since this method more exact in comparison with DNA microchip experiments technique, and as a result, we have a matrix of count of genes which correspond to appropriate type of samples. And firstly, it's necessary, then we use the Cancer Genome Atlas database. The initial number of genes was about 19,000. So this data can be identified as big data. One file was 1 gigabyte. Firstly, it's necessary to remove non-informative and low-informative gene expression profiles. At this stage, the number of genes was reducing to about 14,000, and then we use statistical and entropy criteria to allocate the most informative genes. At the next step, it's possible to implement the cluster analysis, but within the framework of our research, we don't use this step, and then we can grade the disease diagnostic system using appropriate classifier. Within the framework of our research, we use 2 types of classifier or reconstruct gene regulatory network. Goal of the research is presented at this slide. The first step, as I said before, we use data from the Cancer Genome Atlas. Each samples of the initial data contained as attributes 19,000 137 type of genes, while the expression of the corresponding genes is proportional to its activity level. Number of samples, we used 8 type of cancer, various type of cancer, and 9 data corresponding to samples for which no cancer was identified as a result of clinical trials. Within the framework of our experiment, we used 9 groups of samples. The total number of study samples was equal to 3,269. Thus, the initial form of matrix is presented in this slide, rows and columns. The next slide presents the types of cancer disease, 8 type of cancer, and the 9th group contains the normal samples without tumor. General statistic of the numbers of genes, we used the experiment of based on RNA molecular sequencing, and as a result, we had the matrix of count of genes, and values of this count, general statistic of these values variant is presented as this slide. As it can be seen, the range is very huge. And firstly, we transform the absolute values of the number of genes into a relative values, count per million, by the formula 1. Then we remove from the experimental data of unexpressed gene expression profiles by the thresholding coefficient, the value of which correspond to the condition log2 count is 0. So is genes, the profiles correspond to the condition max count less than 1 for all samples, are considered as non-expressed and were removed from the data. As a next step, the values of gene expression are transformed into more convenient range by Amplitude function logarithms for all values of the matrix. Of course, some values of gene expression profiles can be negative in this case, but the negative genes was identified, gene expression values was identified as non-expressed, and the value of these genes was changed to 0. The next slide presents the box plot of the values of genes distribution for 9 genes. 9 genes in this case we presented. And as it can be seen, some of genes has low level of expression. So these genes are not informative for identification of the appropriate disease, and these genes also can be removed for the further investigation. And the next slide, we remove the non-informative genes. We divide the genes to 2 groups, informative and non-informative, by 3 types of criteria: statistical criteria and Shannon entropy. Statistical criteria is the maximum absolute value of gene expression for all samples. The vector of expression genes, values of which are contain the expression of genes for all samples, we name the gene expression profiles. So maximum absolute value of gene expression profiles, variance, and Shannon entropy. And if maximum absolute values and variance is less and Shannon entropy is higher than appropriate thresholding value, then genes has a low level of informativity. To calculate the general criteria, which contains three types of statistical criteria and Shannon entropy, we use the Harriet and desirability methods. Stepwise procedure of this method implementation is presented in next slide. Firstly, it's necessary to transform the linear scales of appropriate criteria to scales of dimensionless parameter epsilon. Range of this parameter change from -2 to 5 by system 2. Then we transform all criterion values to scales of epsilon parameters by equation 3. Then we calculate the private desirabilities for each criteria by equation 4 and evaluation of the generalized index as a geometric variation of all private desirabilities by equation 5. This slide presents also the general statistic of the generalized index values distribution. At this state, we identified the informative genes by thresholding coefficient is corresponding to the first quartile, 0.029438. And genes, the general index value is less, then this value were removed from the data as non-informative. And at this stage, when matrix was transformed into the next form. The next state, we to confirm the effectiveness of the previously steps, we use the classifiers. For binary classifier, we use a random forest algorithm, and for multi-classifier solving task, we use the convolutional neural network. Previously, result of research allow us to optimize the structure of this network. This structure is presented in this slide. We use it two-level, one-dimensional convolutional neural network. Parameters are presented, hyperparameters in this slide. Result. Binary classifier uses a complete set of gene expression profiles. In this case, we form the 8 clusters. For each gene expression data which correspond to appropriate type of cancer, we add the gene expression profiles which correspond to normal samples. So we implement the classification procedure in, as it can be seen, the result is very high. We implement 4 complete sets which contain about 19 gene expression profiles and 4 filtered sets which complex complete complete data application convolutional neural network, and then application in this case complete set of gene expression profiles, binary classification, and we use the binary classification for filtered data, and we obtained almost the same results. Then results of application convolutional neural network for solve the multi-cluster task, 9 clusters in this case. Complete data accuracy is about 97%. I would like to say that this accuracy is significantly larger in comparison with results which are presented in literature for this type of data. So this method of gene expression selection are the next for filtered data. Accuracy difference is 1% is indicates very low accuracy, indicates that the step of gene expression reducing is effective. And I would like to say that at this stage we only implement the step of gene expression profiles reducing, but we have implemented the next step. We have divided the gene expression profiles, selected gene expression profiles using spectral clustering algorithm, and we to implement parallel classification of samples which contains various gene expression data allocated in various clusters, and we take the final solution based on the result of various classification implementation, and we improve this result to accuracy about more than 98%. So this technical indicates that this technical is effective. No, the charge of convolutional neural network training validation and loss function indicates that the training procedure was performed correctly. Conclusion is presented at this slide. Thanks for your attention. A question, please. I am ready to answer for your question.
Thank you, dear Sergey. Question, please, dear colleagues.
Have you tried using meta-heuristics?
No, I have not used meta-heuristic in this within the framework of this research. We compare in previous research. We compare various as clustering and classification techniques, and we select this. No, we compare for binary classifier. We compare decision tree, random forest, SVM techniques, various classifier, and random forest has better results. However, for multi-class task, we also implement random forest classifier and convolutional neural network. And random forest allows us to obtain very good results similar to convolutional neural network, but random forest work for this data about 3 days, and the convolutional neural network about 10 minutes. So in terms of time, convolutional neural network is better. But meta-heuristic methods we don't use within the framework of this research. Thank you for your question.
Thank you.
Thank you. More questions, please? No more questions. Thank you, dear Sergey. Ukraine traditionally has a morning air alarm, but we have asked that all Ukrainian participants take care of their safety and connect to the event from shelters. And so I hope that all participants are safe, and we are continuing our workshop. I kindly ask you to adhere to the time limit of 15 minutes per speaker, 10 minutes for the presentation, and 5 minutes for questions. And now we have a second presentation, information technology for logistics infrastructure based on digital visualization and web cartography under the conditions of military conflicts, by Ilona Dumanska, Olga Pavlova, and Huda El-Bukisi. Ilona, are you speaking? Yes?
Yes. Good morning, dear colleagues. I extend my warmest greetings to all participants of the 4th International Workshop of Intelligent Information Technologies and Systems of Information Security. Today, I am Ilona Dumanska, present as a result of the research on my behalf and behalf of my co-authors, Olga Pavlova and Huda El-Bukisi, on the topic information technology for logistic infrastructure based on digital visualization of web cartography under the condition of military conflicts. Since the beginning of the war, Sorry, 1 minute, please. Since the beginning of the war, the state of the logistic infrastructure has undergone significant changes. As you see, the greatest losses were received as a result of the blockade of seaports, which provides 75% of the foreign Ukrainian trade and caused a food crisis in the world, causing a shortage of grain deliveries to African countries. The ports of Berdyansk and Mariupol remain under occupation even now. This situation led to the reorientation of maritime logistics to land delivery and actualized the development of web mapping for the needs of logistics. Taking into account the destroyed roads, bridges, and railway infrastructure, the following slides presents as a cartographic analysis of destruction. According to the Kyiv School of Economics, as of September 1st, 2022, the total amount of the direct documented losses to the resident and non-residential real estate as infrastructure amounted to more than $127 billion at replacement cost. Regular monitoring of the losses established that for June-August 2022, the three most affected spheres include objects of the logistic infrastructure were destroyed, as you see in the slide. So modern trends of Ukrainian logistics in the military conflicts have some obstacles, and they were presented on the slide. In addition of everything listed in the organization plan, it is important to note a valuable aspect that military action became a catalyst for the repeat of application of information technologies in logistics with a wide application of digital solutions. According to the survey using the Google Form tool conducted in Ukrainian among logistic enterprises of Khmelnytskyi region in January 2022, the author of this publication asked a number of questions, the answers of which made it possible to determine the positive and negative aspects of the development of logistic infrastructure based on these solutions. The key of they were: what is the obstacle of in implementation of IT solution at the moment for you? So we have a such result. That 35% said the difficulty predicting effectiveness from implementation. And the next basic result, it was 23% lack of sufficient implementation experience and specialist knowledge. These results are based on a lack of interaction between technology and logistic business development teams. So the content of digital transformation processes involves a gradual transition from the data digitization to the formation of a multi-component digital logistic infrastructure, the element of which should include fixed and mobile communication and television, geolocation, e-commerce and m-commerce infrastructure, basic logistics business processes, state surveillance, financial transactions, specialized logistic business process, and cybersecurity and digitalization on virtual infrastructure. The presented basic components of the digital infrastructure of logistics based on the modern solution make it possible to significantly change traditional logistic business processes, and information about the location of goods plays a key role in supply chains and logistics. During military conflicts, this became even more apparent to many end users, especially during border raids and traffic congestion. Summarizing the presented information, our team of authors came to the conviction that the development of digital logistic infrastructure based on modernity solutions should be based on the concept of digital visualization and implemented in accordance with the Web Content Accessibility Guidelines developed by the World Web Consortium, shortly called WCAG. This guidance addresses the design of a still environments, programs, and devices and logistics infrastructure for use all stakeholders with the need for adaptation for special designs. Accessibility-based impact 2.0 is overcoming a wide range of limitations, visual, hearing, physical, language, cognitive, and learning disabilities. The basic principles of them were presented on the slide. So visualization technology must meet security consideration from the combination of technologies, data, and images. One such tool is 3D visualization, which is simulation modeling tool to analyze the software products that can be used to build a simulation model of the logistic infrastructure. A comparative table has been created and present to this slide. For comparison, the following tools were used: AnyLogic, FlatSim, Arena, and so on. And on the next slide, you have opportunity to see the examples of visualization of logistic infrastructure based on AnyLogic, Arena, Simulink, and FlatSim. It was noted that on basis of the grant from Polish Foundation Intermarium, in my department use FlatSim. By the discipline Fundamentals of Custom, the students have opportunity to perform their practical task, for example, for placement some custom points and their relocation to build logistic chains and so on. And a fragment of students' work you can see on the slide. It will be example of model visualization by container logistics. And next, I want to state that the cartographic support for logistic operation is based on electronic maps, GPS monitoring system, and savvy paper maps or series of maps of different scales and different density to meet the needs of logistics. The analysis of cartographic source made it possible to conclude that, in fact, there are no complete logistic map in Ukraine. Only the logistics map of Europe is available. Therefore, the development of information technologies for logistic infrastructure is an urgent task. The American Institute of the War was the first to launch an interactive map of military action in Ukraine. This interactive map is analog of static map of Ukraine, but includes geographic data on the direction of military operation. The experience of American Institute for the Study of the War is implemented in domestic projects of Restart Ukraine together with Accelerator Lab. It will be the first picture in this slide. The project's intent is to record and map all incidents of destruction and contamination that must have been in Ukraine in military conflicts. Along with it, in the next picture of this slide, you can see the cartographic document of the state device for emergency situation is present. This map shows location where explosive ordnance has already been detected or is likely to be detected. Thus, the possibilities of web mapping ensure the conditional reliability of the function of the logistic infrastructure of Ukraine in war conditions, the detection and assessment of the scale of destruction, and the possibility of making changes to the logistic routes in real time. In order to calculate the economic effect from the implementation of the logistic company's project decision regarding the implementation of the proposed information system based on digital visualization and web cartography of logistic infrastructure, the following options were determined. Option 1, the logistic company uses the proposed software without any changes, and option 2, the logistic company uses the proposed software with an implemented applications that overlays all the information fields of the interactive maps. On the basis of economic calculation, it was concluded that option 2 will bring the greatest profit. Also, the first glance, this profit, the profit from this option will be not high, but the development implementation cost is not very big, and but due to the ability to respond to the change in view of the military situation, and the logistic company can gain more benefits by avoiding losses from errors in the design of the logistic chains. After confirming the economic effect of the submitted proposal, we developed an organization model for the implementation of the information system of digital visualization web cartography of the logistic infrastructure based on modernity solutions in the condition of military conflicts, which is present on the slide. Its elements include purpose, task, means, principles, influencing factors, priorities and task, long-term goals, as well as a map of indicators of achievement from the implementation of financial investment support, ensuring customer user expectation, training and development, and state of internal management. As a result, we generalize conclusions of the conducted research. They are presented on this slide. Our further research by the authors will be devoted to the development of the methods and algorithm of information technology for logistic infrastructure based on digitalization and web cartography. So my report is complete. Thank you for your attention. I will be glad to give answers to your question.
Thank you, dear Ilona. Dear colleagues, questions, please.
What mathematical methods do you plan to use?
Thank you for your question. When we trying to find economic effect from implementation web cartography and some IT solutions of digital visualization, we're trying to use simple economic methods. For example, it will be a matrix of regrets for better understanding how many costs we will have and have the opportunity to have in the future more high results. And for example, we're using three scenario: pessimistic, realistic, and optimistic. And after some mathematic, we have results that option 1 will be more profitable and give more opportunities for good building logistic change with a good result, and have opportunity to rebuild some processes in the company for the better logistics.
Thank you.
Thank you. More questions, please, dear colleagues? No more questions. Thank you, dear Ilona.
Thank you for all.
Now we have third presentation, radar target recognition based on machine learning by Volodymyr Motyka, Maria Nasalska, Yaroslav Stepanyak, Victoria Vysotska, and Miroslava Bublik.
Hi, nice to meet you. I'm here. Sorry, it's a very interesting moment. It's typically, but I'm close out. Okay. Sorry for inconvenience. Okay, now I'm start my screen sharing. Did you see?
Yes.
Thank you. Ladies and gentlemen, greetings to all participants of the conference. Let me present our work on the topic radar target recognition based on the machine learning done by Volodymyr Motyka, Maria Nasalska, Yaroslav Stepanyak, Victoria Vysotska, Miroslav Bublik. This is unit scientist from Ukraine and Germany, named from Lviv Polytechnic National University and Osnabrück University. February 24th of 2022 changed the life of people in Ukraine to before and after. The war is being waged on the all front, from line, rear, and aboard. At such time, people do everything that depends to them on the how to stay, and more people come to aboard to Ukraine despite to constant danger from the wider side. Almost every day, air alarm saw and various missiles are aimed at our area, include civilian objects. Air defense work extremely well. The problem is that each missile is different in its properties, and this causes certain problem when they intercept them. And this is why preliminary recognition of air target is an extremely important aspect of the protection for the rear and in particular the front. Automatically target recognition is the ability to an algorithm or devices or recognition target or object based on the data received from sensor. This is usually primarily for military and military purposes. This is extremely wide range of algorithm and devices from which data is classified. The simplest version of automatic target recognition is a radar recognition system, a hardware and software technique complex for automatic distinguishes one's troop and weapons from the enemy. The essence of the recognition is established whether a target below or with a certain class based on the result of processing radar signal reflected or emitted from it. In this way, the home aligned system are divided into active, the target emits the signal, and passive, the signal is reflected from the target. And the dataset contains four columns of data. There is the first column described the elevation angle, the second the azimuth, the third is and the fourth the calculate ESA of the missile. This is a third column named ESA. Data is a frequency of measured in megahertz is equal 180, and in the fourth of the comparison ESA is equal 350 megahertz. To use this decision tree, we will combine the data into the two tables, then the column will be described as satellite missile at secondary question and polarization, and the result of this is you present on this slide. After analyzing the dataset, we will briefly describe the attribute we need to further implementation. We have a total 722 data records. This is important in that we have only two unique values of missile, namely AMG 88C and KAPD 352 independent variables, namely angle and azimuth. Our dependent ones is presented in this slide, and now we have exactly the value of variables where it can be, and you can see in this slide. The next step is to create data group for training and testing the model. The test sample will consist of 30% of the data set. For the let's move on to creating to the instance to the decision tree classifying model with the Gini index criterion and the training this model. We will immediately check the accuracy of the build model. In this stage, we will build a graph for the decision tree using the following block of code. The graph view for no readable. So we export the graph resolution using the function of the graph with model. This model allows us to view detailed example of tree solution. In this figure, you can see this simplify the elements of the model more understandably. Let's move to the co-creation to instance for the decision tree classified model with the entropy index criterion and to training this model, and we check also the accuracy of the build model, and you can see the decision tree graph on the Gannon graph. This is display decision tree graph Gini criterion. It's the next slide. You can see the decision tree graph with entropy, and as a result we built the matrix TVE build matrix of inconsistencies based on the result of the last model. Finally, we determine this criterion of the index in the most accurate. Gini index criterion is better, and it has accuracy equal 84.51 point, and as you can see in this slide. And so to the end, one of the doubt of the convenience, the necessary automatic radar recognition, especially nowadays. Creating new and important old model is extremely important during wartime and preventively in peacetime. A model of recognition AGM 86C and Taurus KAPD 350 cruise missile was built, which sufficiently accuracy recognizes this type of the missile. Accuracy is equal 84, about 84%. The model is accurate because one of the missile is sometimes referred as the missile developed using Strers technology. The disadvantage of this model is that the model is trained on only two types of the missile. The problem is that the data in the effective scattering surface of all missiles is services of any stage are extremely confidential. The decision tree method was used, which allows you to immediately highlight the advantages of the model. The clarified of the model has choosing the certain missile. A future problem of the model may be in the increase of the number of missiles to be classified. In this case, it will be worth to consider other methods to build a model such as neural networks. Thank you for your attention.
Thank you, dear Miroslava. Dear colleagues, questions, please.
Which decision tree method did you use?
Only decision we use the decision tree graph you present, and for example we calculate only two methods, Gini criterion by using the Gini criterion and by entropy, and we get that the Gini criterion is the better and accuracy is equal 84.5%.
Maybe C4.5 method.
Maybe.
Thank you. More questions, please? No more questions. Thank you, dear Miroslava. Now we have fourth presentation is narrow fuzzy control of spray drying food machine by Katerina Zubkova, Volodymyr Sherstyuk. Volodymyr, are you speaker? Yes.
Yes, thank you. My name is Volodymyr Sherstyuk. I present research directed to developing intelligent control system for a food machine conducted in Kherson National Technical University. In recent years, artificial intelligence became one of the most popular topics with respect to many industries and technologies. Unfortunately, they do not include the food industry. In this work, we consider the production of tomato powder, which is a powdered concentrate of tomato paste used in cooking to give dishes a specific smell and color. It's produced by drying. The raw vegetable material for that is aseptic tomato paste, 30% dry matter. Tomato powder should match some requirements, including appearance, taste, odor, color, and chemical requirements of the food standards. This slide presents a food machine. Its appearance is on the left and schematic structure is on the right. Drying occurs with the help of air heated in the calf. One moment. This way. The supply of hot air is carried out from above through a pressure jet. Tomato paste is sprayed under a certain pressure through the nozzle, 0.3. To be injected into the primary dryer chamber, tomato paste must be ground and heated. Hot tomato paste is injected under a pressure of 25-30 bar into a stream of superheated hot air. Thus, we have a mixture of drops of superheated steam and tomato particles inside the primary drying chamber. The degradation process is transient, essentially non-linear, and non-stationary. There's also a thermal inertia of both the mass of tomato paste and the heaters. Such processes are poorly controlled due to a lack of mathematical models and ambiguous, imprecise, and incomplete data. Due to operator errors, it often leads to burned powder, unacceptable change in its color or smell, sticking the particle together that entail loss of raw materials and the rise in the cost of the final product.
Dear Volodymyr, you can switch slides. We see your first slide now.
I did not catch.
We see first slide.
First?
Yes?
You cannot see slides?
We see first slide.
Oh.
No
Okay.
switch. Slide.
Let me switch mode.
Okay, now we have you see third slides. Okay.
Thank you. Due to operator errors, it often leads to burned powder, unacceptable change in its color or smell, or sticking the particles together. That entails loss of raw materials and the rise in the cost of the final products. The objective of the paper is to improve control of the tomato paste drying process by developing an intelligent control system for the spray drying food machine, which will be able to take responsibility for the process control and for the high quality of the final product, so accordingly deny responsibility from the human operator. We propose to use intelligent methods to overcome uncertainties and the lack of mathematical models. According to the Industry 4 approach, this task can be solved in two stages. The first stage is perception. We install optical and infrared cameras within the food machine. Therefore, we can use remote sensing and image recognition methods to identify the state of the tomato mixture within the chamber. The second stage is decision making, to generate control signals for the food machine equipment based on the detected deviation in the process flow. Since it is impossible to build an adequate mathematical model or a system of rules that describe the laws of the process, we propose to develop a narrow-fuzzy control system to make control decisions. This slide represents the image recognition process. This process depends on obtaining consecutive images captured by the optical and infrared cameras installed inside the drying chamber. There are two separate channels. There, the channel for optical images and the channel for thermal images. The entire process consists of following stages. Mapping images to the special model defined as a two-dimensional array of square cells, transformation RGB images into HSI color space, averaging values of hue, saturation, and intensity within the cells, filtering images based on the closest colors, and generalization of images based on the defined center color. The thermal image analysis is quite similar. However, to correctly measure the temperature and at the points of the greatest heating, it's necessary to search for bursts of gray brightness on the general uniform gray background of the image. Thus, we use a partial order of gray color presented on this slide. I'm sorry, in this slide. Next slide is about neural network. To identify the state of the mixture inside the dry chamber, we use a 4-layer fully connected backpropagation neural network represented on this slide. The input data are H, S, and I components of each pixel of 3 consecutive images captured by the optical camera. The respective temperature values estimated by the thermal image, and the values of inner chamber temperature, pressure, and moisture content. The log sigmoid function is used as a transfer function at the input layer and the first hidden layer. The Gauss-based radial basis function is used at the second hidden layer. Output signal of the neural network represents the confidence that the state of the cell belongs to one of predefined states. To make control decision, we use a 5-layer forward propagation neural network ANFIS. This slide presents a structure of the automated control system based on ANFIS. Next slide presents a structure of ANFIS model. The development of the intelligent neurophasic controller is based on the Sugella model, ANFIS model, and a training procedure. The vectors of input and output parameters are represented on this slide. On the next slide, there is definition of inner variables used in the model, and in the next slide you can see a general appearance of fuzzy rules used in ANFIS as well. The spray drying food machine, tomato paste, and the possibility of experiment were kindly provided by the company AgroFusion, Holopristen, Kherson region. The ANFIS model has been generated using the FIS editor tool from the Fuzzy Logic Toolbox in MATLAB. A system of 276 fuzzy rules has been developed. The coefficients and membership functions of fuzzy sets have been determined using a MATLAB built-in algorithm. Next, a training sample has been defined using FIS editor, placing the values of the valid verification points. Totally, the training includes 380 epochs. The spray drying machine under the control of an experienced operator has been used to obtain the training sample. The prototype of the control system has been implemented using STM series embedded microcontroller, and using readFIS function generated and trained ANFIS model has been uploaded in the embedded microcontroller from MATLAB. Experimental studies have been conducted and shown that the spray drying machine equipped with the developed intelligent control system can produce tomato powder of high quality without human intervention. This slide shows a diagram of residual moisture dependency on the production time in 2 cases, when the machine is manually controlled in red and when using an intelligent control system in blue. The main conclusion is that proposed intelligent control system based on the neurophasic controller enables reliable and efficient control of the spray drying process. It can take responsibility for the high quality of the final product and so deny the responsibility from the humans. The other conclusions are presented in this slide. Our future research will be directed to joint use of advanced neural network models and case-based systems. Thank you for attention.
Thank you, dear Volodymyr. Questions, please, dear colleagues?
What membership function did you use?
Mainly, it was trapezoidal functions.
Thank you.
Thank you. More questions, please? No more questions. Okay. Thank you, dear Volodymyr. Now we have fifth presentation. That data processing of ethylbenzene oxidation process using the artificial neural networks by Taras Chaikivsky, Bogdan Sus, Serhiy Zagorodnyuk, and Alexander Bauzha. Who is speaker?
Maybe me.
Okay, welcome, Taras.
Share. I think you see my screen
Yes, we can.
and listen me. Dear conference participants, dear scientists and teacher, I am Taras Chaikivsky from Lviivska Polytechnica. I am pleased to present a paper, Data Processing of Ethylbenzyl Oxidation Process using the Artificial Neural Network, after Bogdan Sus, Serhiy Zagorodnyuk, Alexander Bauzha, and me. The research has been made in Lviv Polytechnic National University and Taras Shevchenko National University of Kyiv. The process of catalyst liquid phase catalyst oxidation of ethylbenzyl to benzoic acid is well studied and widely used in the world. Cobalt naphthenate is used as catalyst, but the current state, the catalyst is being improved by adding various compounds which will allow the process to be carried out faster, high conversion, and safe. We used artificial intelligence to process a large array of experimental data and select a best catalyst for this oxidation. Diagram show sequential and parallel mechanism of oxidation reaction of ethylbenzene. Where is my mouse? Ethylbenzene to hydroperoxide of ethylbenzene, and then two ways to methylphenylcarbinol or directly to acetophenone when benzoic acid. In sequential state, the slowest state is limited one, and its acceleration will improve the process. In parallel state, the most productive one is limited, and its acceleration will displace another parallel reaction, and the reaction will process it better in industrial. The system is based on multi-layer artificial neural network for the digital processing of experimental data. The multi-layered, fully connected feed-forward neural network architecture has been selected. A sample of data for neural network training was derived from experimental results. Input parameter is initial concentration of ethylbenzyl hydroperoxide, acetophenone, methylphenylcarbinol, ethylbenzene, concentration of additive, polyethylene glycol, chromoxane, cyanoethyl ether, and time. Output for neural network are final concentration of ethylbenzene, hydroperoxide, acetophenone, methylphenylcarbinol, and ethylbenzene. Yes. The training of artificial neural network took place by training with the teacher. The network training time is about 1,000 epoch. Neural network after training accurately reproduces studied data from a sample of experiment and predict the result of the study in external time range with different catalytic impurities. The obtained prediction allow experimenter to select the most promising direction during the determination for the concentration of active catalyst substances. Next 4 slides present the density of concentration of substances formed during the oxidation reaction of ethyl benzyl with different catalysts. On all figures, red point mark experimental data, blue point are predicted by neural network after training. At first slide, cobalt naphthenate was used as a catalyst. Evidences are not linear. After training, the neural network reproduces the result of experimental and provides intermediate result. Second slide, as catalyst, we use a system cobalt naphthenate and polyethylene glycol. The data presented in figure show that the use of binary catalytic system, cobalt naphthenate and polyethylene glycol, lead to increase the arm of formed hydroperoxide of ethyl benzene in reaction medium. Next slide show result as catalyst. We use a system cobalt naphthenate and chromoxane. The data presented in figure shows an increase formed hydroperoxide of ethyl benzene compared with the use of individual cobalt naphthenate as catalyst, and increase the acetophenone formed during the experiment. Figure left bottom show that the experimental points are poorly correlated with the data issued by neural network. This effect may be explained due to the fact that almost of methylphenyl carbinol is very small. Last experimental slide, as a catalyst, we use a cobalt naphthenate and ethyl ether system. The data presented in figure show that the use of ethyl ether as catalyst additives lead to decrease the overall rate of oxidation of ethyl benzene. This effect of ethyl ether can be explained by the fact that in the structure contain triple bond, and by its nature is an inhibitor of accessing reaction. Studies have shown a significant effect of additive of oxidation of ethyl benzyl. The quantitative and qualitative effect depends the properties of additives and varies widely from acceleration the oxidation process to complete the activation of catalyst. Neural network forecast data allow us to identify ways to increase the effectivity of catalyst process, which make it possible to carry out the oxidation of ethyl benzyl in highest rate of conversion. The proposed approach provides additional data for rapid preliminary analysis of identification of component and of the catalyst process, and reduces the cost factor for raw material and energy. Thank you for your attention. Thank you for your support. Greetings from Ukraine.
Thank you, dear Taras. Dear colleagues, questions, please. I have more questions. What are advantages and disadvantages of your approach?
Once more, please, not listen.
What are advantages and disadvantages of your approach?
Why we use a neural network for modeling of oxidation ethyl benzene?
Yes.
Yes, because catalysts as cobalt naphthenate are used widely in the world, and we add another additional parts of this catalyst to increase conversion to provide with low temperature, and its additives are very more. We have same report using additives for catalyst, and where we using different metal like ferrum, nickel, and same metal. In this report we use it big molecular And I am thinking this is only first start, because next start we need not only I back to input of this neural network, not only concentration of this additives, needs another property of this additives, like, I don't know, maybe size of molecular, maybe molecular weight, maybe electronic potential, or same. Because if we use it metal, different metal, we have number in Mendeleev table or atomic weight. We have different of this. We have property for this inputed. In this case, concentration of catalyst not this way to understand. And we have very more experimental data, because this problem solved not 10, maybe 20 years in our department. And for another process, we have 5 compound, 5 additives to one catalyst system with different property. I think with neural network helping us to understand this process, because in human head not compare with all this data if we look in the sheet of number. Maybe I answer the question.
Thank you. More questions, please?
What activation functions did you use?
My part is more chemical part. Maybe my co-author are all present in this session, maybe answer for this.
Yes, it's the sigmoid activation function has been used for the research.
Mhm. Thank you.
Thank you. More questions, please? No more questions. Thank you, dear Taras. Now we have next presentation. Information technology for predicting the course of climacteric syndrome by Kira Bobrovnikova, Ivan Gurman, Olga Vrushenko, and Olga Gorbatyuk. Who is speaking?
Dear colleagues, I am Associated Professor of Department Pediatrics, Obstetrics and Gynecology. Do you hear me?
Yes.
Faculty of Postgraduate Education of National Pyrgov Memorial Medical University, Olga Gorbatyuk. And I am pleased to present our topic, Information Technology to Predicting the Cause of Climacteric Syndrome. A woman spends almost a third of her life in menopause. This age stage is characterized not only by the end of reproductive period of woman's life, but also a complex reaction of the neuroendocrine system, which may manifest as a combination of neurovegetative, psycho-emotional, and metabolic endocrine disorders. The need for early prognosis of climacteric syndrome is due to the fact that it makes it possible to carry out preventive and therapeutic measures in time to prevent the development and complications of disease. The human body system includes the general health of women, her lifestyle, bad habits, stress levels, and occupational hazards. Constructing models to manage women's health during climacteric syndrome can be challenging due to the complexity and interdependence of various body systems. Furthermore, qualitative factors such as emotions and subjective experiences can also have a significant impact on a woman's health, making it difficult to apply traditional mathematical tools. To address these challenges, fuzzy modeling has emerged as a useful tool to deal with incomplete and qualitative data in the study of complex systems. By incorporating fuzzy logic and fuzzy sets, it's possible to construct models that can account to uncertainty, variability, and imprecision in the data, resulting in more accurate predictions and better informed decision making. An information technology based on fuzzy logic was developed to address the issue of predicting the cause of climacteric syndrome. The information technology incorporates expert knowledge in the field to generate accurate predictions. The proposed information technology is based on the Stroh +10 criteria and uses fuzzy logic. The Stroh +10 system is an updated version of the original criteria, which provides additional information on menstrual cycle characteristics, hormone levels, and age to improve accuracy of menopausal staging. According to Stroh +10, perimenopause and menopause in a woman's life can be divided into 6 periods, each of which has specific effects on health. Next slide. For effective prediction of menopausal syndrome, it's necessary to use an integrated approach to take into account various aspects of woman's condition. The approach involves a 3-step modeling consisting of identifying the stage of menopause, assessing the woman's health status, and focusing potential health problems in the future. By following these 3 steps, a more holistic approach to predict managing menopause can be developed and improve the overall health and well-being of women going through menopause. Next. In order to determine at what period of menopause a woman is, it's necessary to obtain data of variability in the duration of menstrual cycle, the onset of amenorrhea, and the period of the last menstruation. The variable X0 indicates how many years amenorrhea lasts. According to this value, it is possible to determine at which period of menopause a woman is. The next step is to determine the state of health of the woman at the time of the examination and to establish the presence of health disorders, if any. For this purpose, a cognitive map was created, which identifies the factors that affect a woman's health and how strong this influence is. In order to establish the presence of violation in the health of a woman, it's necessary to analyze the questionnaire, what the doctor fills out during examination. By creating a cognitive map, many factors were identified that characterize a state of a woman's health. The occurrence of disorders in hormone-dependent organs and body systems of a woman of menopausal age depends on 70 main input parameters, X1, X17. These parameters can be attributed to 7 subsystems, Formula 1-7. The presence of disorders in hormone-dependent organs and body systems of a woman of menopausal age is defined as total indicator of the initial parameters of the described subsystems, Formula 8. The predicted value of possible disorders in hormone-dependent organs and system of body of a woman of menopausal age is determined according to Formula 9. Next slide. To calculate the assessment of violation of each period, it's necessary for each indicator to set an assessment of the weight and obtain the value of variable under study. For example, an assessment of violation in the current period can be obtained according to Formula 10. A feature of a system based on fuzzy logic is that such a system contains a decision-making mechanism based on expert information, based on the knowledge and experience of experts in the studied subject area, and importance of each linguistic variable was determined. The development of a fuzzy model involves defining the basic term set T and the domain of definition X for all linguistic variables. Table 5 summarizes this definition. In addition to this definition, graphs and membership function for each linguistic variables are constructed. To implement the information technology, a rule base was built consisting of certain blocks of rules. The rule base provides a way to model the complex interaction between input intermediate variables and the output variable, and can be used to make prediction about women's health status based on her individual characteristics and medical history. For example, block of rules for variable Z1 consists of 243 rules. Examples for unclear rules are presented on the slide. To assess the effectiveness of developed information technology, a retrospective analysis of the data of 112 women who sought help from the Khmelnytsky Municipal Perinatal Center in the period from 2015 to 2020 for various gynecological problems and had a normal menstrual cycle was carried out. All women were over the age of 45. To make a prognosis after obtaining the informed consent of patient, personal data of patient were collected using specially designed questionnaires. With the help of the developed information technology, the collected data were analyzed in order to obtain a forecast of course of menopause. When women reached menopausal age, the predicted results of the course of menopause were compared with the actual observation of the patients. Therefore, based on results presented in Table 2, the developed information technology is considered to be effective in predicting the severity of climacteric syndrome, both moderate and severe. It provides doctors with valuable data that can be used for preventive measures against predicted disorders. Thank you for your attention.
Thank you, dear Olga. Questions, please?
What inference algorithm did you use? Mamdani, for example.
Human models is very interesting and very variable system, and we use for prognosis not me, but my mathematical colleagues use models of fuzzy logic, as I understand. I'm gynecologist. I'm not mathematic.
Thank you.
Thank you for your question.
Thank you. More questions, please? No more questions, okay. Next presentation is mobile information system for determining the level of creatine in food products by Tatiana Говорущенко, Денис Класницький, Ольга Говорущенко, Irina Zasornova, and Artem Boyarchuk. Irina Zasornova is speaker. Please, welcome, Irina.
Just a moment, please. You can see?
Yes, yes, we can.
Okay. Topical of research, mobile information system for determining the level of creatine in food products. Authors Tatiana Говорущенко, Denis Pasnitsky, Olga Говорущенko, Irina Zasornova, and Artem Boyarchuk. Today in Ukraine and the world, the problem of the spread of the COVID-19 pandemic is very acute. The second actual problem in Ukraine and the world is the increase in the number of spinal muscular atrophy diseases. Creatine this allows muscles to remember their initial state, and in combination with rehabilitation exercise to return the previous functionality also has a property of increasing the body's perception of oxygen and a protective effect on the nervous system. Creatine is nitrogen contain carboxyls excite that participates in energy exchange in muscles and nerve cells. Figure 1 shows the reference values, normal values, and values of the creatine level in the body of a real person, a 36-year-old man suffering from spinal muscular atrophy, which confirms the low level of creatine. The main source of creatine are meat and fish, but dairy products and berries can also contain creatine. On the slide, you can see the amount of creatine in some products, but there is no information about the presence of creatine in other products, for example, in various meat products. The study of food products to determine the level of creatine in them is an actual task, taking into account the need for this substance for patients with COVID-19 and spinal muscular atrophy. As the survey of research showed, the known tools and system for detection and determining the level of creatine are mainly focused on detection creatine in biological fluids, blood, urine, etc., or in food supplements, but not in food products. Science health of the creatine required by a person enters the body with food. And creatine can enter the body not only as part of various expensive food adjectives, but also from food products. Therefore, its purpose of our research is to develop a mobile information system for determining the level of creatine in food products. Let's conduct an analysis of the subject area on the detection of creatine by Papper's method based on the Jaffe color reaction in general. Papper's method based on the Jaffe color reaction consists of the following steps. You can see them on the slide. At home, you can use a tool. Such a tool is tested paper strips. In the presence of such test paper strips, a person needs only 1. To pour the analyzed sample broth or decoction into the dish. 2. To put a paper test strip in it. 3. To put the dish in a boiling water bath for 15 minutes. 4. To evaluate the color of the analyzed sample on the basis of which to draw a conclusion about the presence and level of creatine in the studied food product. Therefore, a mobile information system for determining the level of creatine in food products was developed precisely to evaluate the color of the analyzed sample and form a conclusion about the presence and level of creatine in the studied food product. Then the rules for evaluating the color of the analyzed sample in order to establish the presence and level of creatine in the studied food product will have the following form you can see in the slide. Considering the analysis of the subject area, the method of determining the level of creatine in food products by the user consists of the following steps you can see in the slide. Considering to develop rules for evaluating the color of analyzed sample in order to determine the presence and level of creatine in the studied food product, the method of determining the level of creatine in food products by the mobile information system consists of the following steps you can see in the slide. The developed method for determining the level of creatine in food products by the user and the method for determining the level of creatine in food products by a mobile information system are the basis for the mobile information system for determining the level of creatine in food products, which will be implemented in the form of mobile application, which on the basis of the determination of creatine concentration by analysis of the intensity of RGB forms a conclusion about the presence and level of creatine in any food products. The structure of the mobile information system for determining the level of creatine in food products is presented in figure 4. In figure 4, you can see the structure of the mobile information system for determining the level of creatine in food products. There was a search for a rule among the rules for evaluating the color of the analyzed sample in order to establish the presence and level of creatine in the studied food product. Rule 1 triggered, so the user received the conclusion creatine is absent in the studied food product. There was a search for a rule among the rules for evaluating the color of the analyzed sample in order to establish the presence and level of creatine in the studied food product. Rule 2 triggered, so the user received the conclusion creatine is present in the studied food product, but the level of creatine is low. There was a search for a rule among the rules for evaluating the color of the analyzed sample in order to establish the presence and level of creatine in the studied food product. Rule 4 triggered, so the user received the conclusion creatine is present in the studied food product and the level of creatine is high. On the slide, you can see the conclusion. Thank you for your attention.
Thank you, dear Irena. Questions, please?
Yes. I wanted to ask a question. So on the slide 11, you had a scheme. Can you please describe it in more details about how is it working? Yeah.
Thank you for your attention. Just a moment, please.
Yes, the 11th slide.
I understand. In the figure 4, you can see structure of mobile information system for determining the level of creatine in food products. A paper test strip after 15 minutes stay in analyzed sample in a boiling water bath. Next, scanning the color of a paper test strip using a smartphone camera. Next, recognize the color of paper test strip by analyzed RGB intensity. Next, comparison of the perceived color of the paper test strip with the scale for evaluating the color. Next, to knowledge base, data section and rules section. The rules for evaluating the color of the analyzed sample in order to establish the presence and level of creatine in the studied food product. Next, rule 1, if yes, to creatine is absent in the studied food product, if no, to rule 2. Rule 2, if yes, to creatine is present in the studied food product, the level of creatine is low. If no, to rule 3. Rule 3, if yes, to creatine is present in the studied food product, the level of creatine is average. If no, to rule 4. Rule 4, if yes, to creatine is present in the studied food product, the level of creatine is high. If no, we need two problems. We have two problems with color recognition. Repeat the scan of the test strip.
Thank you. More questions, please?
Which machine learning method are you planning to use?
Just a moment for the question. Most method also require preferment of samples and expensive equipment and reagents. That is, they can only be performed and laboratory conditions. As the survey of research showed, the known tools and system for detection and determine the level of creatine are mainly focused on detection creatine in biological fluids. The correctness of the proposed mobile information system for determine the level of creatine in food products is confirmed by the correct determination of the level of creatine for all three products, pork, lard, chicken, and pork.
Thank you.
Thank you. More questions, please? No more questions. Thank you, dear Irina. And now we have last presentation for this subsection, information model of the Unisphere QM platform for creation and using the smart content to education by David Arian, Roman Kvetny, Oleg Bisikalo, and Yuri Bunyak. Oleg, are you speaker? Yes. Switch on your...
Yes.
Okay.
I am ready. 1 minute, please. Do you see my presentation?
Yes, we can.
Can I start?
Yes, welcome.
Thank you. Thank you. Dear colleague, participants of international workshop, my name is Oleg Bisikalo. I am from Department of Information and Intelligent Information Technology, Vinnytsia National Technical University. I am glad to meet you at the international workshop in Khmelnytskyi. It is a great honor for me to present you the study results of authors team from Israel and Vancouver. Topic of my report, information model of the Unisphere platform for creation and using the smart content for education. I will present you next subtopics of our paper. Introduction, objective of research, and main results, modeling of the subject area of Unisphere platform, the knowledge base model of Unisphere platform, and the results of the technological implementation of the proposal model of the Unisphere platform. Improving the education quality is the multi-dimensional problem, what includes many interrelated tasks such as knowledge assessment, assessment of behavioral characteristics, assessment metrics, effective development of children's creative abilities on the basis of gamification in the process of schooling is an urgent task of computer education. In high-grade solution, we allow, for example, to create the digital educational products ranging from an application on to comprehensive games where everyone student can contribute games or building blocks for exciting games. We need to create the information model of a Unisphere platform of the creation and use the smart content for learning. This informational model formalizes a new functionality of a Unisphere platform according to the idea of moving education from instruction to construction for a Unisphere platform. The researching goal is the formalization of the subject area and functionality of the Unisphere platform according to the outlined on this slide requirements and the building the applicative software shell for the Unisphere platform. Let's consider the model of the knowledge base of the Unisphere platform. In general, we will present the knowledge base of proposed model in the form of 5 next sets of information objects, operators, predicates, functions, and rules. The information objects of the model is particular are students, teachers, and other users. The educational project game, the learning process, additional data required for the functional of the platform. In turn, generalized information object can be represented by relationships what detail the elements of the set of I/O and allow to consider it in terms of relational data model, such as relationships, attributes, tuples. Formally, the first information object is the set of 7 relations shown here in this slide. On this and previous slide, you can see the formal definition of these relationships according for equation from 3 to 9. For example, user themes at the education 6 is the relationship which characterizing for composition of the user students team. On this slide, the considered relationships 3-9 of the first information object of the knowledge base model represented as the database base schema. The next part of our results is the knowledge base model of a Unisphere platform. In equation 1 for the model of a knowledge base, KM, the components of the 5 were also marked the operators, the predicates, functions, and the production rule. Formally, the operators are defined by equation 10 as a set. In particular, operator Alpha-1 Activation 11 allows use to build user-team relationship, where predicates are defined by activation value. Each predicate from, let's say, a certain set is a test for existing any relationship. For example, team star ID is a verification of a composition of a team of students with the code ID, education 13. The component of a knowledge-based model is also the set of functions, activation 14. For example, beta 1 is the function of publicizing or the balanced composition of the student team, which is entered into the database. And the beta 2 is the function of calculation the value of the selected criterion of the balance for the composition of the student team with the code ID. Finally, on this slide, you will be able to see the set of L production rules what are used to implement the scenario of creating the game educational product. So next part is the results of the technological implementation of a proposed model for the Unisphere platform. What do we use for the proposed implementation? Angular was used in the project to build the Unisphere platform interface. It is a platform for creating and development effective and complex single-page application. Tailwind CSS was chosen the CSS framework, which allows you to quickly create modern website without breaking away from HTML. Using the Unisphere platform is not difficult. After the first login to the platform, the student immediately gets to a page with questionnaire where he indicates his interests. In the future, they will be used to a team creation algorithm. The result of such a survey can be seen on the graph rows of interest in this figure. Using the interest of users, the basic algorithm of the platform generates a team of 8 or 9 students, dependent on the wishes of the school manager. The slide shown the example of a command page, which the list of participants and the team schedule, where each student has a separate column. Taking into account such information, the administrator can change participants between different teams and appoint a leader of each of them. After the final formation of the teams, each of them receives a task divided into state of development. In the task, you can set the deadline and create separate subtasks. Conclusions. A model of the main database and its add-on in the form of a knowledge base based on the 5 sets and proposed, which allow to fully formalizing of the information and intellectual support of the Unisphere platform. The proposed structure and components of the model, unlike the existing ones, allow to ensure the implementation of innovation functions of the platform, taking into account the formal characteristics and requirements of the educational process. On the basis of proposed information model, software for the Unisphere platform was developed and tested in some schools in Israel. The technological platform Angular, Python, GWT, and Amazon Web Services was chosen for software implementation of the Unisphere platform. Thank you for your attention.
Thank you, dear Oleg. Questions, please.
Are you planning to use an expert system?
Yes, we made expert system in education process, and gaming approach can be used in our schools and universities to with the goal to create new educational content.
Thank you.
Thank you for
Thank
the
you.
question.
More questions, please? No more questions. Thank you, dear Oleg. Now
Thank
this
you.
subsection is over.
Sorry, dear organizer, I have a request for you to let me start my next presentation, because tomorrow I have the speech in the same time. It's so difficult to collaborate.
Okay,
to
okay,
speak.
okay, welcome.
Thank
Okay.
you very much. I'm starting my presentation. All this okay?
Yes, we can see.
Yes, thank you. Ladies and gentlemen, let me introduce our research on the topic World University Strategic Analysis based on the data from Q-Query assignment World University Ranking, done by Miroslava Bublev, Oreslava, Victoria Vysotska, Lyubov Kolyasa, and Olga Vlasenko. Now, this is our agenda, its introduction, and now we talk about the main goals, seeds, literature review. In this section, we will talk about our literature and program structure, and and then will be results in our discussion. All experiments conduct would be show the interpreted within this block in all apply to the Quacquarelli-Salmond World University Ranking. It's based on is a variety of data, the source of which is unique. Quacquarelli-Salmond World University Ranking have universities according to 6 indicators: research, teaching, opinions of employment, and career potential, and the number of international students and teachers. To participate in the ranking, a university must be offer undergraduate and graduate program at a list of 2 board subject areas. For example, art and social science, engineering and technology, law and business, etc. The Quacquarelli-Salmond ranking focused on the reputation of university in academic circles. Different in this criteria is the method of the evaluation of higher education institution used by the member of the leading rating after the results. The final position of high education institution is the ranking table depend on them, and this is our main goal to work with develop this concept to the strategic analysis of the rating position, which can be used for forecast purpose. We will try to get a little close to explore the data collected by the Quacquarelli-Salmond World ranking and find answer to question for when factor or requires to the development strategy of the World University Ranking. Novelty is certain trend and pattern are affect the competitive position of any higher education institution in the world. Regional and additional market of education service have been identified. It is proposed to develop a comprehensive system of information and analytical support for the university's development strategy. Task: to solve the problem first, available to evaluate the method of solving problem, analyze advantages of this solution, and justify the key components of the ranking of university by the level of the encouraged employee, creating sustainable working conditions for them, improving the quality of education services. Literature review. I'm only short place. This is presented the rating name and the dynamic of the Lviv University National Lviv Polytechnic National University, and now we have so the large-scale military operation changed this opportunity for the Lviv Polytechnic National University. Now we have present the methods and data visualization. The next step is generalization of the data set and smoothing and resmoothing. We use the smoothing and resmoothing for strange form method with Kendall formulas as results. In research of the Quack-Farrell assignment university ranking by the dynamic of university indicator, we consider the data which was created to help government leader, politicians, and public figure better understand the need of the aspiration of university in improve the development. This histogram is a way of graphically present tabular data in this distribution. To display data in the form of histogram, we use this function. Program code is implemented in histograms, which depicts the statistic of the rating university. On this graph, we have on this slide we have a graphical presentation of cumulated of the source indicator, and on the left figure we have the graphical presentation of the cumulator for the score indicator. On the right graph, we have the graphical presentation for the influence indicator, quality of faculty indicator, and quality of education indicator. And what we can see, the result of method of smoothing time series presented on this slide. We have the smoothing interval for W equal 3, 5, 7, 9, 11, 13, 15. This is shown in this figure. The result with the formula of the Polaroid as the correlation result presented on this slide. As you can see, we used the basic method of visualization, graphical display, and primarily statistical processing of numbering data. Approximation simultaneously of initial data university ranking by the method of linear smooth is carried out. Discussing the obtained result of the rating analysis, this indicates the possibility of their use as part of the economic method for processing information about the current stage and prospects for the development of business process in higher education institutions. This is make it possible to make balanced management decisions based on the objective information about the development of business processes and in universities. In short, analytical review information notes based on the results of the analytic of rating position in accordance with specific needs, which enables university management with the help to the process method of collecting statistical information and its process of analysis to form the necessary database confident, integral, and accessible for the formation of plan for the development of higher education institution. Now for the conclusion, and they are. The proposed method of strategic analysis in the rating position can be used for forecasting in accordance with the set goal. This is also contribute for the development of the comprehensive system of information and analytical support for the university's development strategy. The proposed method of strategic analysis through university ranking has several limitations, among which the most significant is the constant change of the quantitative and qualitative composition of rating participants. Therefore, the rating position and its change, growth or decline may not indicate the real position or real positive or negative development of the university, but it's only a relative indicator. It's important to understand what the position is relate not only for the number of universities under the include these properties and but also to change it in their quality characteristic. Thank you for your attention.
Thank you, dear Miroslava. Questions, please?
Why was exponential smoothing selected?
Yes, it's a very similar method for trending the is using for the build model for forecasting, and for this situation we have so more than 100 universities in this ranking, Quacquarelli, Simon Well University rankings, and we use it for getting this trend and to use it for the future modeling for the choosing the strategic is a method used in strategic analysis when we investigate the environment, specific environment for our business. Yes.
Method ARM, for example, more power.
Yes, I think about it. It's a good idea. I will use it the next time. Yes, it's really a good idea. Thank you.
Thank
Thank you. More questions, please? No more questions. Okay, thank you, dear Miroslava.
Thank you very
And
much.
now the section is over. Thank you all for interesting presentations, for discussion. Now we have a time for coffee break. Our first session will continue at 2 p.m. And after coffee break at 11:30, we have a session second, which is devoted to systems of information security. And you're welcome to session second at 11:30. Now we have a coffee break. Thank you all.
Thank you so much.
you.
Oleg.
Thank you.